Now in this video, we're trying to give you a complete example of regions with holes. So let's start with this region D that is inside um, the boundary C1 and outside boundary C2. Note that C1, the outer one is counterclockwise and inner is clockwise. In a previous video, we discussed that's when we cut the region into two pieces that without holes, that's the directions that we want to get the counterclockwise for the two regions, basically two cut regions. So that's the good one. Therefore, according to what we explained, what we need to do is basically add FDR on C1 plus C2 FDR. And this is going to be equal to the double integral on the region, the shaded region D of curl of F dA in Z direction. Now let's compute curl of F. What is curl of F? Curl of F is, this is P, this is Q. So Q sub X minus P sub Y is going to be 1 minus 1 plus 1 is 2. So this piece is 2. There is a little information given about area, and that area is area of the region, shaded region is 8. So if I'm taking the integral on this side to dA, that means just 2 times the area. Equal to 2 times 8, which is 60. Now, my next thing is that to compute F dot dr on C1. That is turning out to be not an easy task to do. First of all, I don't even know what the parameterization of C1 is. So the goal of this problem is to calculate that without even knowing the parameterization or what kind of curve it is. So this is the one that I'm computing with a question mark. And it turns out that I actually can compute one of these line integral easily. Because C2 is the unit circle, I can just find the line integral of that. So the point in here, and I can find the line integral of that in the clockwise direction and then subtract, basic counterclockwise direction and then subtract. So my plan is to find it counterclockwise. So I can do R of t equal to cosine t sine t, R prime of t equal to negative sine of t and cosine of t. Then f of R of t is going to be P of R of t is cosine t minus sine t. Q of R of t is cosine t plus sine qt. Then F dot R prime is going to be negative sine of t cosine of t plus sine squared t plus cosine squared t plus cosine t sine qt. these two add up to 1. This is -1/2 of sine of 2t. So the integral is going to be from 0 to 2 pi of -1/2 of sine of 2t plus 1 plus cosine of t sine qt dt. The integral of this one is symmetric by symmetry. Above and below the x-axis, this is going to be 0. Integral of 1 is going to be 2 pi. A u substitution will give me minus sine to power 4 t over 4, 0 to 2 pi, which is going to end up to be 0. So this is going to be 2 pi. So integral f dot dr on C1 is going to be equal to 2 pi plus 16.